welcome to week 4 of Code Club. This week, Alice and I are going to talk to you about how to use lists to manage your program's data, making copies of sprites with cloning, detecting events, and broadcasting and receiving messages. Open up another browser window and log into Scratch so you can follow along. Have fun and let's start coding. Lists in Scratch are a special type of variable that holds a bunch of other variables. So it's basically a tool that you can use to store multiple pieces of information all at once. In other programming languages, they're called arrays. So if you hear me say array, I just mean list. So why would you want to use something like a list? Some examples I can think of right off the top of my head are, what if you want to keep, you have a character in your game that has a backpack and you want to put a bunch of stuff in the backpack. Well, you can put all the different types of things in the backpack by putting them into a list. What if you're doing a lot of different calculations? So you have a square and you want to know what the area is and you want to know what the volume is and you want to know what the perimeter is. You can put all of those into a list. When you're doing pen drawing, like we talked about last week, one of the things you want to do a lot of the times is keep track of the previous position of where the pen was so that you can do something with older pen drawing, parts of your pen drawing, so you can use a list to keep track of that. When we talk about cloning in a little bit, which is later in this video, in cloning you use lists a lot to keep track of all your clones. The first thing we need to do is make a list, and if you're in the data set of blocks, it's pretty easy. You click make a list and you give it a name just like any other thing. So I'm just going to call it backpack for now. We'll see what we do. And once you make a list, it'll show up over here. You can turn it on and off with the little checkbox here, just like any other variable. I'm going to leave it on though, just so you can see what happens as I do things with it. The first, easiest thing to do is add things to a list. And, if we add an event for when clicked, go back to data, say add thing to backpack. And I'm just going to leave it like that, just so you can see what happens. Click play. Now our backpack has something in it called thing. And, if I add other things to it, let's try other thing. And we'll do one more here, and we'll say thing 2. So now you can see there's a bunch of things in there. One thing you'll notice if you look at, I did add thing, add other thing, add thing 2. If I click play, it's just going to re-add all of those things to my backpack. And it's because when you restart your program, it doesn't clear out that list. You actually have to use the delete all of backpack at the beginning of your program if you want it to clear out every time. So now if you look, every time it does it, it clears out what was in there before and adds it in there. So typically you'll want to do this when when the green flag is clicked, but there are other times it happens as well when you want to clear everything out of your backpack. If you notice, when I pull out the delete block, it's a drop down here that says delete 1, delete last, delete all. So delete all is the one we used already, and that deletes everything out of your list. Delete last does exactly what you'd think. It deletes the last thing. So if you look right here, it's got thing 2. If I run this real quick, thing 2 gets deleted because that's the last thing in the list. If I do it again, other thing gets deleted because it's the last thing in the list. This other one, where it says 1, this deletes the item at whatever position you want. So there's 1, there's 2, there's 3. I can put 1, 2, or 3 in here and it will delete any of those. You can also use a variable to do this. So if you have, some coding going on in your script and you let that, randomly choose a position or something like that and put that into a variable, then it will delete that variable, that position that's listed in that variable out of your list. If you want to add new things to an existing list, there's the insert block. And so if you see here, I have insert new thing at a position of the list, which is called backpack. If you drop this down, it's got the same options as delete, which is, a number, last, or random. So last will put it at the end of your list, random will put it at a random place in your list, and then 1 puts it at a specific position that you can drive through a variable or something like that. The replace block actually looks in your list at the position that you say. So again, just like delete, there's 1, there's last, there's random. It looks at the position, what's in there already, and replaces it. So if I run this real quick, I'm going to put number 2, and I run it, and now number 2 has changed from other thing to replacement thing. So that's what replace does, is it takes an item in your list and replaces it with something else. The item block lets you pick an item out of your thing. So it'll pick, one that's driven by a variable, or the last one, or a random one, and spit that back out as output. So if you want to say, I'll just choose random. So say a random item out of the list for 2 seconds. Now it says thing 2. It chose the last one. If I run it again, it says thing 2 again. It's random, so it'll choose one randomly. Now it chose replacement thing because that's the one that's there. So this just lets you get an item out of your backpack. You can use it in, a say. You could use it with an operator, like to compare 2 different list items or something like that. So that just lets you get an item out of your backpack and use it for something. The length of list block lets you get the current number of items in the list. So my list has 3 things. If I put this in a say and run that, it'll say 3 because there are 3 items in the list. Where it gets really interesting though is if you're doing a looping. So let's say repeat some number of times. Now we can repeat length of backpack times, and we need a loop counter in there too. So I'm just gonna set looper to 1, and then change looper by 1, and then right before this I'll put that say again. So say, and then we'll get the item and looper. So now what this is going to do is it's going to loop through every item on my list and say the current one. So the first time through it's going to say 1, the next time through it's going to say item 2, and the last time through it's going to say item 3. So if I run this real quick, thing, other thing, thing 2. So this is where the item of operator becomes real powerful, because you can start using it to loop through your list and do things with everything in your list. If you want to test if something is already in your list, you can use this list contains operator. And what you do is, in something that needs an operator like an if test, you pull that in there. So I say if backpack contains thing, say in list, otherwise say not in list. So if I run this, it should say in list because I have something called thing. Okay. If I change this, I'm just going to change it to be thing 25 because I know there's not a thing 25. And I run it, it's going to say not in list. So this tests to see if this thing listed here is in the list. And this can be a variable, so you can go through in your program, and if you have a variable that contains something you think might be in the list, you test that variable against your list and see what happens. Clones are a way in your program that you can have multiple copies of a sprite. And all of those copies can have some different properties, like the position can be different, the direction can be different, they can use different costumes of the sprite. If you use if tests in your code, they can have different scripts running at the same time. So clones are a really powerful way to make a bunch of different copies of your code. Of your sprite. One thing I want you to know is this is different than using the duplicate button up here on the scratch bar. If you look, this actually creates a new sprite called cat2, and that is not what we're doing when we create a clone. A clone is the exact same sprite every time. It's not a new sprite that's being created. Why would you want to use clones? Some good examples that I can think of are if you have a game where you have multiple enemies in it that all do basically the same thing. Each of those enemies, instead of having to create a bunch of different sprites, could all be the same sprite but a clone of each other. If you have a lot of buttons in your program, so you have a start game and a stop game and get high score, like these are all buttons that you might press in your game, that could all be clones of one sprite that has a bunch of different costumes with some code for each of the different clone types. If you have a card game, that could be a good place to use it too. You could do, one clone, your primary sprite is the deck of cards that you have, and each clone is a person's hand in the thing, in the game, something like that. So there are a lot of different ways to use clones. Usually when you use clones, they rely pretty heavily on lists to keep track of what's going on with them, so we'll talk about that a little bit as well. This is a real simple example of how to use clones. I have a snowflake sprite, and when I click the go button, it creates a bunch of copies of the snowflake sprite. And they're all different sizes, positions, directions, and then it waits a second and those all fall. So let me just show you how it works real fast. So it creates a bunch of them, different sizes, different positions, and they all fall down like snow is falling. And every time I click the flag, it creates a new version of it with different positions and sizes and all that kind of stuff. So the clone code that you need to know is I have create clone, that's what creates the copies. And if you look here, I have it in a repeat that picks a random number. So that's how I get a different random number of clones of my snowflake every time. Then in my snowflake code, I have when I start as a clone. And so what this does is the sprite detects if it's starting as a clone. And if it's starting as a clone, it does different code than when the green arrow is clicked. And so here's where I have it choose a random direction, I have it choose a random size, I have it choose a random position, and then I also have it start falling down based on this code as well. The other big clone operator is delete this clone, which has to go at the end of your when I start as a clone. And I could have used it here in place of hide. It doesn't really matter. There are some places where it will matter though, like if you're doing a game where you're fighting against a bunch of clones of the same sprite, you'll actually want to delete that clone out, and you shoot the clone and it's supposed to go away. You actually want to delete it so that it goes away instead of sticking around and using up memory and stuff on your computer. This example gives you a little bit of a sample of how you can use if tests and variables and lists to keep track of your clones as you create them. So basically what I do here is I have a loop counter called clone number, and basically every time I create a new clone, I'm going to increment that by 1. I also have two lists, one called clone X positions and one called clone Y positions, and those are basically the X position and Y position of every clone that gets created. So I create 5 clones, I add 5 items to those X and Y lists, I increment clone number all the way up to 5, and I create 5 new clones. When I start as a clone, first of all, I have a variable called myCloneID, which each clone gets its own ID. Then if it's number 1, I go to a certain position. If it's number 2, I go to a certain position, and so on all the way up to 5. And then if you look here, I'm adding a blank item to the X position and Y position. When it starts as a clone, I'm setting the number at myCloneID, which, for 1 is going to be 1, 2 is going to be 2, 4 is going to be 4, etc. I'm setting that position of the X and Y position lists to be the actual X and Y position of this clone. So if I click play here, you can kind of see what happens. Each clone gets created. They all have their own unique ID that you can use to reference them. And then if I look at the two lists, X positions and Y positions, number 1 has the position of this clone, which is -144X, 99Y, and all of them are a little bit different because they're all in different positions. The next big topic I want to talk about is the events category of blocks. And I'm not going to go into these in too much detail because they all work pretty much the same way, and we've used a lot of them already, but I want to just cover them real quick. So there's when green flag clicked, and that is when you click this green flag, that's what starts your program. When a key is pressed, so this looks at your keyboard, and if one of these keys is pressed, so if I choose U, it's when I press the U key on my keyboard, it will do something. There's when this sprite clicks, so if I click on Scratchcat, it will do something, and there's an equivalent one in the backdrop for when the stage is clicked, and that means anywhere that isn't on a sprite. So if I have 20 sprites on my screen, if I click anywhere else on my screen that isn't a sprite, that one will run. In both a sprite and in a backdrop, you can have when backdrop changes. So if the backdrop switches to a different one, do something. This one is kind of cool. It interacts with your video camera or your microphone or with the timer. So if the loudness of your microphone is greater than a certain amount, or if the video motion is greater than a certain amount, it'll do something. Or if you have a timer running, if the timer is greater than a certain amount, it will do something. These last ones are for what we call broadcasting, and I'm not going to cover that. We'll cover that in a couple of minutes here. For any of these, for when green clicked or when a key pressed, you can have multiple copies of this on your screen on your script at the same time. So if I have 3 different when green flag clicked blocks on my script, and I have one do a move 10 steps, and I have another one say hello for 2 seconds, and I have another one turn 15 degrees, all 3 of these are going to happen at pretty much the same time. So there are valid reasons to do this, but it can get confusing if you do it, so just be careful. I think an important usage of the when green arrow clicked event is when your program first starts up, usually your backdrops and your scripts all need to be in a certain state. So if you look, this is the game where the scratch cat follows my mouse around until it hits a red wall and then it explodes. Well, I just finished the game and it's exploded. But if I click the green arrow again, I want it to be on the cat costume, and I want it to be in a certain position, and I want it to be pointed in a certain direction, and I want to make sure the sprite is showing. So right at the beginning of my script, I switch the costume, I go to a certain position, I change the direction, and I make sure it's showing. And usually at the beginning of your script, you're going to want to do that for all of your sprites and all of your backdrops. Have just a little bit of code that changes everything on your script back to the original location, original position, whatever you need to reset back to, somebody can restart the game very easily. And this is actually probably a pretty valid use for the having multiple green arrow clicks. So if I were to do another green arrow here, now I have one that just resets everything, and then another one that runs the code for my game. So that could be a valid usage for having 2 separate green arrow clicks on there.
Hey everybody, so the next topic is broadcasting. And these are the blocks that you can use to broadcast. The when I receive block, the broadcast block, the broadcast and wait block. Broadcasting lets a sprite send a message, and it lets another sprite get it. For example, if one sprite says jump, other sprites, if they are listening, do something. This is an example of using broadcasting. When I click the ball, the blob comes down and watches it roll. In the ball script, when I click the ball, it sends a message called ball. In my blob script, it listens for the ball message. When it hears it, the blob runs the code to move down to the ball.
The last thing we want to talk about was the difference between broadcast and wait. And the difference is actually kind of exactly what it sounds like, which is broadcast and wait will wait for all the sprites that listen for the message to finish their code before it continues its own code. So I have a real simple example set up here. So in my backdrop, I have a clear graphics effects, then I have a broadcast or a broadcast and wait, and then I change the color effect of the backdrop by 25, which sets it to like a peachy type of color. In my sprite, when it receives the message, it says hello for 5 seconds. And what you'll see, in this one, without the broadcast and wait, it's going to change the color and say hello at pretty much the same time. Okay? So that's pretty simple. Now if I change it to the version with broadcast and wait, what's going to happen is it's going to change the color back to white. It's going to say, the cat's going to say hello for 5 seconds, and then it's going to change the color back to the peachy color. So you see that long wait there was waiting on this script to finish running. So if you have something complex going on, like, a complex pen drawing or something like that, that is your message receiver, it will wait for that to finish before it comes back and does the rest of the code in your script that sent the message. Alright, that's it for week 4. Hope you enjoyed it. Now go do some coding on your own. Have fun, be creative, and we'll see you next week.